Thank you, sir. Jazakallah.
बिस्मिल्लाहिर्रहमानिर्रहीम। टॉपिक हमारा था एफजीआई एंड प्रोटेक्टिंग ग्रुप्स। उसके अंदर ये हमारी कोर्स आउटलाइन है। लास्ट टाइम वी हैव डिस्कस एफजीआई ऑफ अल्कोहल्स ऑक्सीडेशन रिडक्शन रिलेटेड चीज़ें से हमने डिस्कस की। नाउ वी आर गोइंग टू डिस्कस इमीडिएट डिस्कनेक्शन ऑफ कार्बन डबल बॉन्ड कार्बन, जिसको हम विटिक रिएक्शंस कहते हैं, और डिस्कनेक्शन ऑफ इराइल कीटोन्स। एराइल कीटोन्स और कार्बन डबल बॉन्ड कार्बन की डिस्कनेक्शन है। विटिक रिएक्शन, क्योंकि इसमें हमारा मेजर जो है विटिक रिएक्शन ही है, इसलिए मैंने उसको एक टॉपिक दे दिया। इमीडिएट डिस्कनेक्शन ऑफ कार्बन डबल बॉन्ड कार्बन, Wittig reaction. Wittig reaction is a very famous reaction. Number of modification are occur in Wittig reaction. बहुत सारी modification हो चुकी है ना इसके अंदर। तो double bond, in the synthesis Wittig reaction, it is the double bond formation. Tri-alkyl halide react with triphenyl phosphine. Phosphorus elite will be obtained. It react with carbonyl compound. Then you will obtain double bond in between two carbons. So this is the Wittig reaction. Disconnection approach. Double bond will be broken. Then you will obtain carbonyl compound one side, and the another side triphenyl phosphine. This is the Wittig reagent, and this Wittig reagent is obtained by the reaction of triphenyl phosphine and alkyl halide. The alkyl halide react with this one. What are the advantages of Wittig reaction? It is very short route for the formation of carbon double bond carbon. The double bond must go where we want it. जहां हम चाहते हैं वहीं double bond आएगा. Meaning the double bond is formed between this carbon and this carbon. Immediate disconnection. अच्छा, disconnection भी आप करेंगे तो immediate disconnection होती है, immediate formation होती है. Now we discuss some examples related to Wittig reaction. Analysis of this compound. It has double bond. Disconnection approach, there are two, A option and B option. For the first option, you will disconnect the double bond. There are two options here, CHO, carbonyl compound, and this one is the Wittig reagent, phosphorus helix. The second option, this one will be the phosphorus helix, and this one is the carbonyl compound. This compound further disconnection triphenyl phosphine and alkyl halide, and this compound uh, carbonyl compound, the cyclic compound, six membered ring and double bond. So retro deals elder disconnection, butadiene and dienophile. And this triphenyl Wittig reagent further converts it into alkyl halide and triphenyl phosphine. So B is preferred than A. Why? Because this reagent is not readily available. If you will see the catalog, then अगर आप कैटलॉग देखते हैं तो ये reagent नज़र नहीं आता, तो अब ये आपका रूट आप समझते हैं कि ये प्रीफरेबल नहीं है। यहाँ पे क्या है कि जब आप ये देखते हैं तो ये फर्दर सिंप्लीफाई हो चुका है, अल्काइल हैलाइड ये अवेलेबल है। एक बात, दूसरा फिर जब इसको फर्दर आप डिस्कनेक्ट करते हैं तो बोथ रिएजेंट्स आर अवेलेबल। तो अवेलेबिलिटी, it is always important. B is preferred than A regarding the availability and simplicity of the starting material. Synthesis, we will prefer route B than A. Butadiene and dienophile. This is Diels-Alder reaction. Then you will obtain this compound, cyclohexene. Then the second alkyl halide react with triphenyl phosphine. Then you will obtain Wittig reagent. This is the Wittig reagent or phosphorus elite. Then the reaction in between carbonyl compound and phosphorus silate, you will obtain the double bond in between this carbon and this carbon. The double bond is formed. This is your target molecule. Analysis of another compound, compound number 7 in the series. This is the compound you will disconnect here because this is the key point, and uh, more branches are near to functional group. You will disconnect here. Then this is the carbonyl compound and alkyl magnesium halide Grignard reagent. If you will disconnect the alcohol, then this is the root, the alkyl magnesium halide react with carbonyl compound, then you will obtain alcohol. Further, FGI for this carbonyl compound reduction, carbonyl group is converted into alcohol, hydroxyl group. And again, this is the hydroxyl group. You will again disconnect alkyl magnesium halide and carbonyl compound because both react, and you will obtain alcohol. Now the synthesis. This is the alkyl magnesium halide react with carbonyl compound, form this alcohol. Addition reaction of nucleophilic addition reaction of carbonyl compound. First, this is the carboxylate, metal carboxylate, hydrolysis, you will obtain alcohol. Then oxidation, by the oxidation in presence of chromium oxide and pyridine, the alcoholic group is converted into carbonyl group, aldehyde group. This primary alcohol is converted into aldehyde. This aldehyde again react with alkyl halide and magnesium, and hydrolysis, same process, same steps. Alkyl magnesium halide and hydrolysis, you will obtain your target molecule. This is the secondary alcohol. Another example of compound, this is your target molecule analysis. It has double bond. There are two options. The first option is Wittig reaction. This is the first option. And second option, you will convert double bond into OH by FGI. Then alcohol will be converted into carbonyl and alkyl magnesium halide. There are two options. The first option, this one, Wittig reaction. This one, this is the Wittig reaction. So there are two options. If you are interested to disconnect double bond, first option is Wittig reaction. The second option is you will convert into hydroxyl group. Then you can disconnect into carbonyl compound and alkyl magnesium halide. It depends on the availability of the compound and simplicity of the starting material. So here you can apply Wittig reaction. And another example, it is converted into hydroxyl group by FGI. Then you will disconnect here carbonyl compound and alkyl magnesium halide. Alkyl magnesium halide, and this will be converted again into epoxide and phenyl magnesium bromide. Tertiary alcohol is readily dehydrated. ये जो टर्शरी अल्कोहल है ये तेजी से डिहाइड्रेशन हो जाती है, तो हम इसको देख सकते हैं. Synthesis, epoxide and phenyl magnesium bromide. This phenyl negative attack on this epoxide, we have already discussed about the epoxide in the previous lecture. Phenyl attack here, the bond will be broken, then it is converted into alcohol. Phosphorus, this alcohol OH will be converted to bromide by using a strong alkylating agent, phosphorus tribromide, phosphorus pentabromide, thionyl chloride, thionyl bromide. This is the alkyl bromide. react with magnesium in presence of ether, then Wittig Grignard reagent will be obtained, react with carbonyl compound, and hydrolysis alcohol will be obtained. By the dehydration, in presence of phosphoric acid, you will obtain the target molecule. Another example, disconnection of aryl ketones. Ninth in series. This is your target molecule, disconnection of aryl ketone. There are two options, A and B. Two options. In A option, you will disconnect here. This is the Friedel-Crafts, this one, this is the benzene ring, and this is the acyl chloride, like Friedel-Crafts acylation. The second is B option. This is the acyl chloride, and this is the benzene hydrogen here, CH2, CH3, toluene. A is preferred than B. Why? Because this is the Friedel-Crafts acylation. It is very common and you can introduce easily. But here in toluene, if it will react with the toluene, you will not obtain this type of product. Toluene means methyl group is already present. It means ortho position or para position, the acylation will be occur. So here we do not need ortho or para position of the toluene. The toluene is not here. So we prefer this disconnection. A is preferred than B. The synthesis, this is the Friedel-Crafts acylation, Lewis acid, ferric chloride, this is benzene ring, and acyl chloride, Friedel-Crafts acylation, and you will obtain here uh, and Friedel-Crafts acylation, this oxygen, and just like methoxy group and ortho para directing group. So ortho para directing group and para will be preferred because steric hindrance of on ortho position to para position here and para position here. According to this one and this one, you will obtain similar products. Another example of disconnection of aryl ketone. Aryl ketone means the ketonic group is attached with the benzene ring. This is the example analysis. Number of this is the benzene ring system. Methyl is attached. Methoxy group is attached. The another benzene ring system, nitro group is attached. Again, two options, A and B. In A option, you will disconnect here, then you will obtain acyl chloride and nitrobenzene. In the B option, here you will here acyl chloride, and this is the benzene ring. Why A is not preferred? B is preferred than A because nitro group is meta directing, methoxy group is ortho directing. Why? Because if you will react this system with the acyl chloride, then this is the meta directing. The acylation will be occur at meta position here, but we require para position. So we cannot prefer A option. In the B option, acylation will be occur ortho position of this methoxy group because the ortho position of methoxy group and ortho position of methyl group. Methoxy group is more activating group as compared to methyl. So the active this side is more active as compared to this ortho. Ortho of methoxy is more active, more reactive as compared to ortho position with respect to methyl. So acylation will be occur at ortho position with respect to methoxy group. So we prefer B as compared to A. So in synthesis, we will perform B route. This is the paramethyl and methoxybenzene, acyl chloride, ferric chloride, Friedel-Crafts acylation, then this is your target molecule will be obtained ortho position with respect to methoxy group. So these are the disconnection of aryl ketone regarding the Friedel-Crafts acylation reaction of aromatic system. इसमें आप ये भी देखेंगे कि जो ग्रुप्स लगे हुए हैं उनमें एक्टिवेटिंग कौन से हैं, डीएक्टिवेटिंग कौन से हैं, एंड विच ग्रुप्स जो हैं वो मैटर डायरेक्टिंग ग्रुप्स हैं और ऑर्थो पैरा डायरेक्टिंग ग्रुप्स हैं, और उन ग्रुप्स को आपस में यू विल कंपेयर कि विच वन इज मोर एक्टिवेटेड एज कंपेयर टू अनदर वन. ये सारी चीज़ें को देखते हुए आप डिस्कनेक्शन भी करेंगे, देन यू विल परफॉर्म द सिंथेसिस. जी कोई क्वेश्चन यहाँ तक? जी कोई सवाल?
नो सर.
ठीक
जो है उसमें क्वेश्चन किस तरह से बन के आ जाता है कि हमें पता चले किस तरह से तैयारी करनी है इसकी?
क्या बन के आता है? क्या
क्वेश्चन सर.
क्वेश्चन का पैटर्न क्या होगा जो आज आपने पढ़ाया, उसके अंदर क्वेश्चन का पैटर्न क्या होगा ताकि हमें पता चले किस चीज को याद करना है, कैसे कैसे याद करना है?
कैसे कैसे याद करना है?